I'll be talking briefly about semiconductors. A diode is a p-n junction of a doped semiconductor element such as silicon, where impurities are added in the form of donors and acceptors, where acceptors will take electrons and donors will give electrons. The property of the diode is to allow current flow only in one direction. Similarly, BJT transistors have two junctions, NPN configuration or the PNP configuration, and they can have similar behavior than two diodes placed together. However, the difference between a transistor and two discrete diodes is that transistors will allow for reverse bias current whenever there is enough current going through the base. So, for example, in an NPN transistor, initially the current is not allowed between the collector and the emitter because the state is considered to be off. And if enough current flows through the base, this will allow enhanced voltage or current flow from the collector to the emitter that will follow proportionally the current in the base.
In this experiment, I'll be using a BJT NPN as an amplifier. So what I have done is place a resistor between the source and the collector. That will be our output voltage. And then a reading will also be taken by the base and emitter. And that will be our input voltage. So the blue line represents our input and the yellow line represents our output. So starting from 0 volts from our base and emitter, going to 0.2, 0.3, 0.5, 0.6, and the yellow line, it's right now matching the source voltage. And if I decrease the voltage, the input voltage, it starts going back down to 0. So our blue line is moving, but it's just moving the amount of voltage that we apply, which is very little, in this case going from 0 to 0.6. But suddenly we have an increase in our yellow line, which is our output voltage, and essentially that's the property of a transistor. We're allowing for current to flow according to the amount of current we put in the base, for, in this case, for an NPN BJT. So yeah, basically this is one demonstration. In this experiment, I'll be demonstrating the implementation of two amplifiers. The first one will be our amplifier of our audio signal here, that it's going to be transformed into an optical signal. And then on our second circuit here, we have a second amplifier which is going to interpret those optical signals and then is going to play the sound through this speaker. So if I just hit play here, then there's audio. Now you can see the oscillation on the light, which is how it transmits the music basically. So if I block this, there's no audio. So because this is being transmitted optically, again, I block the signal.
And this was all for this presentation. Thank you.